For today's class, as you all are hopefully aware, we're going to be doing the Unit 3 review session today. So basically, I'll just be going over the practice test. Additionally, just make everyone aware of, well, the quiz that was due last night, but as some of you saw, my math lab was down, and so I just pushed the quiz back to tonight. Currently, my math lab is still acting up. So I guess we'll try to see how far we can get with the practice test. But hopefully everything gets cleared up and you can do the quiz for tonight. There's also a homework tomorrow for normal distributions. So quiz tonight, homework tomorrow, and then of course there's the practice, the practice for the Unit 3 assessment. Again, this is an optional exam. You can do it or you don't have to do it. I recommend trying it at least once on your own. Just hearing me talk about it and nodding along in agreement, it may not translate over too well. But again, it's just like how the Unit 1 assessment was. You take it on your own. There's no supervision, no proctoring, nothing like that. You take it on your own. It's a 70-minute test. Or if you have time and a half, it's, I think, 105 minutes. But there's no partial credit either, so you have to be very careful about, especially how you type things into the calculator. So that's hopefully what I will be able to go over today. Let's see how well this works with us today, my math lab. But yeah, so homework or quiz tonight, homework tomorrow. Talk about the practice test today, and the assessment opens up on Wednesday. And you have until Thursday. Latest time you can start is by, I would recommend 10 p.m. Does anyone have any questions for me before we get started? And this should all be encapsulated by the email sent out last night about all the reminders. So if there's nothing there, then let's go ahead and see how well we can work with my math lab, because again, it's been kind of glitchy today. So, okay, so we'll start off with simply the difference between the highest and lowest data values. Hopefully you know that definition. It's the range. So that's definitely the range. Simple definition-based problem. Sure. Okay, I'm recording. All right, so the range, pretty straightforward. Let's go on to the next one. And yeah, it's probably going to delay a little bit. So, okay, so they give us a data set here. They have this little table over here of values, and they want us to determine what's going to be the best measure of central tendency. Not even what is the measure of central tendency. They're just asking for what would it be. So we don't even have to put this into the calculator. It's all speculative. So does anyone have any intuition?
E.
What's that?
E.
You say D?
E.
Oh, E, sorry. So why E?
Basically, because of what it says, it is affected by the outlier, but it'll give.
Oh yeah, I guess that would make sense because of what it says. Yeah, that's a fair point. So yeah, definitely. Did you want to add something? Yeah, so I guess yeah, the median because of exactly what it says. Definitely E because there's an outlier ultimately. There's an outlier. This guy right over here, that 84.6. Yes.
So I want to be
A. I wanted B.
A.
A. So well, the mean is you never use the mean when you have an outlier.
Okay.
And notice this 84.6, that's way different than all those other values, right? So that as soon as there's an outlier, it makes your mean biased. So the mean cares about every value. It takes all those values into equal consideration. The median, not so much. It just cares about how many values there are. So the median is, you always want to use the median when there's any presence of outliers. If there's no outliers, then the mean is great to use. So the median, and you definitely don't want to choose F even though they both make the same initial claim, this one says it, wait a minute,
That's what I'm thinking first.
it's F.
It's not. I think on the homework, it was telling me it was E.
Yeah, on
Because I
homework,
had that same
on
question.
homework, it told me it was F.
It is not affected by the outlier. The median's not affected by the outlier.
Yeah, when you say it was E, it's back in my head.
Well, I mean, median's not affected by the outlier. So, well, that's what I'm going to go with. It's not affected by the outlier. So medians are, I mean, in statistics, median's known as a resistant measure. It's resistant to outliers. So I'm going to go with F. See, kind of tricky happenstance here. So, yeah, so I definitely say that the median is not affected by the outlier. So, yeah, so I'm going to conclude it's F. I'm going to change my mind. We can always check it at the end. If I'm wrong, then, I don't know. I guess I'm wrong. We'll find out. I think it's F for now. We'll find out later. Does anyone have any questions for the time being? If not. Okay, so again, I think it's F. Find out later. Let's go on to the next one. Okay, more definition stuff. If n% of the items in a distribution are less than a particular data item, we said that data item is in the n percentile. It's, percentiles refer to when you are a certain percentage above other data values. Again, the example I used in class was talking about ACT scores. If you score in the 75th percentile, it means you did better than 75% of students. Percentile. So another definition. Let's go ahead and look at problem 4. Okay, we have a normal distribution with a mean 100 and a standard deviation of 10. Find the number of standard deviations. This measure of 67 is from the mean. So if we have some measure like 67, how do we figure out how many standard deviations it is from the mean?
Subtractive.
What's that?
Do you subtract it from the mean?
So we're going to subtract. There is going to be a subtraction between the values. So we're looking for, whenever you want to figure out the number of standard deviations from the mean, you're normally going to come across a z-score at some point, because the z-score gives you a nice formula to work with. And the z-score and the number of standard deviations are almost identical. We'll figure out why they're not exactly identical, but they're very, very close. So the z-score, the formula is always, you take the value that you want to convert, or find the number of standard deviations of from the mean. You subtract by the mean, which they gave us as 100, and then divide by the standard deviation, which is 10. So what is that, negative 33, so that's negative 3.3. Let's find out. I was unsure about problem 2, so maybe my confidence shouldn't be trusted. 67 minus 100 divided by 10. Okay, cool. So we have negative 3.3 as the z-score. That doesn't exactly answer the question, but we're pretty much right there. The only reason why negative 3.3 will not be the answer is because it's asking for standard deviation and not a z-score. Standard deviation cannot be negative, but the z-score can. Basically, the z-score takes the standard deviation and the context into consideration. So the number of standard deviations is always the magnitude, as in there's a negative sign, just get rid of it. It's always the absolute value. The z-score is still negative 3.3, but the number of standard deviations is positive 3.3. Because again, the standard deviation cannot be negative. So that's a very common mistake I see. And again, on an assessment that you don't get partial credit for, imagine losing all those points because you kept a negative. So I want to emphasize that to everybody, make sure you all are aware of that situation. Does anyone have any questions up to this point? Okay, cool. Let's move on to problem 5. Okay, this problem might seem familiar. So it's a half a cup serving, something about 180 calories, 6 grams of fiber. And they want us to find all those values instead of half a cup. What about 2/3 of a cup? And so there's seems to be a separate answer for calories, a separate answer for grams of fiber. This ultimately ends up being a proportion problem. So if we know that half a cup corresponds to 180 calories, then that proportion, in terms of looking at 2/3 of a cup, it's going to be, well, some number of calories that we would like to know. And then once you set up a proportion, generally the way we start these is to cross multiply. We can go ahead and cross multiply here. And the way that'll look is 1/2 times x is equal to 180 times 2/3. Just to make the intermediate step explicit here. Well, 180 times 2/3, that's I think 120. So that's 1/2 x is equal to 120. Let's make sure that's right. 180 times 2 divided by 3 is 120. Finally, there's just one more thing we have to do. Anyone care to provide me that last step? What's that? We're going to multiply by 2 just to clear out that denominator. Cancel, cancel. Because anytime there's a fraction, it's normally good to get rid of those. And then the remaining 1 times x is just x. 120 times 2 is 240. And that gives us the number of calories. So it's a fairly menial proportion problem. And we can do the same thing for grams of fiber. Half a cup corresponds to 6 grams of fiber. About 2/3. It's pretty much the same problem, just there's a 6 in the denominator instead of a 180. Cross multiply. 1/2 x is equal to 6 times 2/3, which is 4. So 4 is 6 times 2/3 after we cross multiply. Then we clear the denominator. We get that x is 8. So that concludes this problem. Does anyone have any questions before we proceed? Hopefully that one's pretty straightforward. All right, you all might remember this problem. So yes, that does mean we're gonna go straight to the calculator with this one. It may be worth following along with me because you could do the whole problem right, but you mess up on one number. It's good to see what some weakness might be so you can correct it for when you do make your way to the assessment. So we just run through how to get to the edit screen for any of you who might have forgotten. Click on Stat, and then enter on Edit, so we can edit the values in. And we can all go ahead and start typing in values. I'll give you all a second to go and type those in. Okay, so once you type in all the values, you should of course have 46 values as mentioned in the description. And the first thing they want is for us to find the median. So remember, the process for finding the median is the same for finding the mean and the standard deviation. You have to press second in mode to quit out after you input all the values. Go back to stat, go to calculate, and we're going to utilize one variable, statistics. Now, your calculator, just keep pressing enter. And if we all typed in everything correctly, I might not have typed it in correctly, but if we did, we should all have the same, at least the same mean, the same first value. So is your first value 45.8043? Is that what you have? So I'm going to trust majority here. I'm going to trust that everyone else got that. If you did not get this, then make sure you're very careful about how you put everything into the calculator. Again, a lot of people will just miss a number or accidentally, instead of 46 somewhere, I'll put 56. It happens. But for a problem like this, that's probably worth a lot of points. It's worth double checking it. It really is. But from here, provided we typed in everything correctly, they want us to find the median. And the median, just scroll down a little bit on the calculator, it seems to be 46.5. You can also go ahead and put in the first and the third quartile, which the calculator also graciously provides for us. So that seems to be 37 and 54, respectively. 37, 54. And then once we know the median, the quartiles, especially the quartiles, we can go ahead and figure out the fences. So remember the fences, this is a formula you might want to have nearby. I'll go ahead and do the fences up top. I'll do the upper fence, which is Q3 plus 1.5 times the IQR, which we'll figure out the IQR in a second. And then the lower fence, which is Q1 minus 1.5 times IQR. Now the IQR is the interquartile range. It's the difference between the quartiles. So the quartiles we found. The quartiles we found, the interquartile range, again, is Q3 minus Q1, 54 minus 37. So is that 17? So now we can use the IQR, plug that straight into our formulas for the upper and the lower fence. Q3 is 54 plus 1.5 times the 17. We'll get some number there. Q1 was 37 minus 1.5 times 17. And so let's figure out what these two values end up coming up to be. 54 plus 1.5 times 17. We get 79.5 for the upper one. And then for the lower one, 37 minus 1.5 times 17, 11.5. So from here, we have the fences, but there's 4 answer choices here. And it's pretty much asking us if there are any outliers, because remember, the fences tell us the boundaries for which all the values, all the regular values should lie in between. If there's any values that are larger than the upper fence or smaller than the lower fence, then those are considered outliers by definition. Well, one quick way to determine this, well, if we go back to the one variable statistics, tells us that the minimum is 21 and the maximum is 75. The minimum is above the lower fence and the maximum is below the upper fence. There couldn't be any values that exceed in either direction. So there's no outliers because there's no values that fall outside of that boundary. So I'm going to pick answer choice B in particular because none of the values fall outside the outlier. That makes sense. Outlier, outside. And they just want us to provide the fence values. So we have that the upper fence is 79.5, the lower fence is 11.5. So we have that for the upper and lower fence. After that, they want us to create a box plot of the information, in particular the 5-number summary. Now it might be more helpful because this part below, it does say, let's determine the 5-number summary. So the 5-number summary is always the minimum, Q1, the median, Q3, and the max. So we'll go ahead and start off with 21, 37, 46.5, and 54. And then the maximum, 75.
You start from the minimum, right? The min.
Yeah, you start with min-x. And then from there, the calculator gives it to you in order. So you can always just follow from the calculator's ordering. So it's better to figure out the 5-number summary first because the box plot is based directly off of this. If anything, what it says is that the first part of the furthest part to the right should align with 21. It seems like this has a pretty good alignment with that. This one, I guess it depends on what the step sizes are. It could be maybe by 2s, 2, 4, 6, 8. No, it's not 2s, maybe 4s. 24, 28, 32, 36. So it seems to go by 4s. This would say that the minimum is 25, which is not true. We found it to be 21. So if anything, these out. So what about the other two that are not being shown right now? Looks like answer choice B would also be ruled out because answer choice B says that the minimum would be about 25. So that leaves us to either A or C. Now, one thing I noticed is that the first quartile it's a little bit before 40, and the first quartile for this one is after 40. So one's less than 40, one's greater than 40. but our first quartile is 37. So it has to be A. Have to have 37 for that first one, but 37 obviously is not to the right of 40. So it can't be this one either. And you can use other values, it looks like, to also confirm this, but it's definitely answer choice A. Our process of elimination. Okay. And now the final part. So you might remember this problem from when we did it in class. It pretty much works out the same way. The typical score is, in this case, the median, because they don't want us to look at the mean in this problem. We're on the assumption that the median and the 5-number summary is the way in which we choose to analyze this problem. So the median, with half the games totaling more than blank but less than blank. Does anyone remember these two?
Can you scroll up?
More than 37.
Well, all you need is right here.
More than 21, less than 75.
So
More than 21, less than 75.
More than 37, less than 54.
it's more than 37 and less than 54 because you only want half. 21 to 75 is 100% because that's the lowest and the highest. So, so yeah, 21 to 75 would be 100% because that's the minimum and the maximum.
Right.
So you have to go a little bit further. The quartiles are what denote the middle 50%. So it's more than the first quartile, but less than the third quartile. And what about only 1/4 of the games have the team scored fewer than blank? What about this one? Who remembers this one?
That's one 37 too.
Say that again?
That one be 37 too.
It's going to be 37 as well, because what's lower than 37? Remember, each one of these jumps is always 25%. If you start at 21, you can't go any lower than that. So that would be 0%. So you have to go to 37. Then everything fewer than 37, you go to 21. That's 25% of the data, or 1/4. And then the most is 75, but just the largest data value, which is asking for the most. That's probably one of your more engaged problems here. I wouldn't be surprised if one like this pops up on the assessment. Does anyone have any questions before we move on? If not, let's go ahead and look at problem 7. So we can see what section this refers to by the instance of the word ratio. So they want a ratio of what they call the incumbents' votes to the total number of votes. Remember, a ratio is just a fraction of values. So we have to start off with the incumbents' votes. Well, it seems like they say 7,000 for the incumbent. So that's easy. That's the numerator. And then the total number of votes. What's the total number of votes here? What's that? So you said X? So the total number, we know the total number.
17, or, I'm sorry.
You add up all the numbers,
So what do you get from that?
7,100.
Well,
No, I think 8,000.
we get 8,000.
But if you look up,
7,000 plus 700 plus 300. Adding up all the values. So that's the total number of votes. So that's 7,000 over 8,000. And they want a whole number or a simplified fraction. That's just 7 over 8. Never really have to deal with x's and ratios. Those are more proportions. Because in proportions, we're normally looking for one of those values somewhere. Okay, cool. Next problem. Okay, let's keep going. All right. So this problem states there's some normal distribution. So it says that the average height of for women is found to be 68 inches with a standard deviation of 2.6. They want us to know the range of the middle 95%. The range of the middle 95%. So range implying that there's some interval that we're trying to find the boundary values for. And all they give us, well, they tell us the average height of 68, the standard deviation of 2.6, and then middle 95%. Now, I'll keep this as generalized as possible. How does any of this information help us at all?
I mean, 68 is the mean.
Well, the 68 is the mean. How do we, well, what would we do with that mean? Or what would we do with this standard deviation? Or what would we do with anything? How do we proceed with this problem?
It's just that the deviation, like people like on number line, and like two.
Yeah, you're getting closer. You're getting closer.
We'll add and subtract from them.
Well, so that implies that you're looking at one standard deviation away. But what tells you that we may be looking at one standard deviation? Why not two or three? The middle 95%. There's something called the 68, 95, 99.7 rule. And what this rule tells you is how many standard deviations that you look at from the mean. This is one standard deviation. This one's two. Next one's three.
199.7.
What's that?
199.7.
That's just part of the rule. So they told us they want to know about the middle 95%. Guess what? 95 is the second part of the rule. So what they want us to do, the interval values are two standard deviations from the mean, whatever the average is. And of course, there's two of them because we can go below the mean and above the mean. So what this tells us then, the middle 95% tells us two standard deviations from the mean. So now the question is, how do we find these two? Well, they want us to put this in ascending order. I've had people flip the order. It drives me crazy that I can't give partial credit for that. But ascending orders, please, don't put me in a, rough situation and not have to give you points because you mixed up the order. So to find two standard deviations below, so how do we find that?
We must subtract the 2.6 from them. Okay, and
It's yeah, we're going to take so it's below the mean. Standard deviation tells us the increment sizes, but we have to do that twice because we want two standard deviations. So we have to do that twice. And then two above, I might as well write that one out. Pretty much the same problem, we just add. Because we're looking for above the standard deviation. So let's do 68 minus 2.6 times 2. 62.8. And equivalently, you can go ahead and find the value 2 standard deviations above. Seems to be 73.2. And these represent our 2 interval values for 2 standard deviations from the mean. 62.8 and 73.2. Again, ascending order. Don't switch these 2 up or it's going to mark the whole problem wrong. And I'm not allowed to give partial credit on this test. So that would be very unfortunate for me to see and not be able to do anything about. Okay. Does anyone have any questions before we move on? Okay. Let's look at the next problem. A score in the 50th percentile is the median. True or false? Well, I guess there's not really much to ask. This is true because the median, by definition, is above 50% of the data. The median is the middlemost point in the data set. So by definition, and the 5-number summary will also help us understand this. So that's 2 different ways we can think about it. There's the minimum, and then Q1, and then the median, Q3, and then the max. Then 50th percentile means you're higher up than 50% of the data. So the median is larger than this amount of data. There's 25%. There's 25%. 25 plus 25 is 50. So that's a few different ways to think about it. So this is a true statement. Just like how the first quartile is the 25th percentile. And the third quartile is the 75th percentile. Same argument. Okay, so they give us a simple proportion. Let's go ahead and figure that out. So there's nothing really to do here other than remember a little bit of algebra. 16 times 11 is equal to x times 8. 16 times 11 is, I don't know, some number. 176 is equal to, stylistically, I like to put the number in front of the variable. Really doesn't matter because you're just going to divide by 8 in the next step. I think this is what, 22? Okay, so cool way to figure that out without having to, so the reason I was able to figure that out, this is kind of, not really having to do with the exam. 16 times 11 is equal to 8 times x. If we break up 16, it's 8 times 2. Then pretty much all we're doing is canceling out the 8s. Then you're left with 2 times 11, which I knew was 22. So just a little bit of, stuff to kind of help you. So that has nothing to do with the exam. That's just, sometimes those help when you break down numbers into smaller numbers. And sometimes you get nice results from that. So, okay, let's move on. Okay, so they give us pretty small data set for the most part. They want us to find the range and the standard deviation. So pretty much our job is to just make sure we type this in right and know what we're looking for. This should be a pretty straightforward problem. Add it in the data set, clear out the old one from that basketball problem. Make sure I typed in everything correctly. 52, 78, 90, 96, 93, 83, 80, 53, 55, and 39. So the way we find, well, if anything, the range and standard deviation and all the other values that are pertinent to this class, they're one variable statistics. Now, they tell us the standard deviation immediately. They want 1 decimal place, so that's 17.7. But if they ask for 1 decimal place, if you put 2 decimal places, it'll mark you completely wrong, and I can't give any points for that. So please make sure you see these little MyMathLab nitpicks here. Again, that's doing the problem is not too bad in this section, but these MyMathLab nitpicks will definitely, you know, make you lose a few points if you're not careful. Now the range, the problem actually does not tell us the range explicitly, but it tells us something that helps us find the range. Well, the range is the max minus the min, and the calculator gives us both of these. Max is 96, the min is 39. That's it. You get 57. Just the max minus the min. So it implicitly gives us the range. Does anyone have any questions about this problem? All right, let's keep going. Okay, so this is one of those weighted mean problems that we did. So there's a midterm that's 5%. I'll kind of breeze through it a little bit more quickly than last time when we talked about this one in class. So the midterm is 5%, and the student scored an 81 on the test. So I think I did this problem slightly different the second time I taught it. I'm going to do it the more intuitive way, but the old way that I taught it in the class notes is not wrong by any means. So this student scored an 81 on the midterm, and that was 5% of his grade. Now, I think when I taught this in class last time, I wrote that 5 as a decimal, but here I'm going to end up putting a denominator, which I did not put before. I think this is more intuitive when we think about mean as some computation in the numerator divided by some total value in the denominator. I think this is more intuitive because we think about mean as a quotient, ultimately, if you do this by hand. Okay, so that's the midterm. Then we have to add that to, well, the next grade. There's a class project that's 20% in the project. This person got a 99 on it. So they got a 99 on the project, and that counted as 20% of their grade. Again, I'm using the percentage value, and I'm not converting it to a decimal for a reason I'll show when I fill in the denominator. All right, let's do the next one. Homework, 40%. Homework's, the student got an 84. So they got an 84 on the homework, and the homework is 40% of their grade. And we have one more. Final exam, 35%. They scored a 69 on the final exam. Okay, so that's 69 times 35. Okay, so from here, again, when I did this problem in class, I wrote all the percentages as proportions. But I think this way I'm doing it is a little bit more intuitive, because naturally with means, even weighted mean problems like this one, we divide by something. as is typical with the mean formula. You divide by the total number of occurrences. Question is, what is the total number of occurrences? What that ends up being, well, how many points are in consideration here? 100. That's how many. The 20%, 40%, 35, and so basically how grade distribution works. All the points add up to be 100%. And so if you want to think about it as towards why is this way and the previous way equivalent, that 100 turns all of those percentages into proportions, because 5 divided by 100 would be 0.05, or 20 divided by 100 would be 0.2, and so on and so forth. This is a more, in my opinion, a more intuitive way of thinking about the problem. This is 81 times 5 plus 99 times 20 plus 84 times 40 plus 69 times 35. Close the parentheses, divide by 100, and the student finishes the class with an 81.6%. And they want one decimal place. We already had one decimal place, so you don't really have to change anything. Okay. Suppose let's keep going. Okay, so they give us the mean, the standard deviation, and they ask for what the score is that is 1.5 standard deviations below the mean. So in this problem, you need to figure out, well, what are we given and what are we looking for? I'm going to ask you all this. Do we have a z-score, or do we need to find the z-score? We do have the z-score. They are asking for what is the score, but that's referring to a test score. Just so happens the thing that we are wanting to know about is they happen to call it a score, purposely to manipulate you into working this out in a different way. We already know the z-score from all of this. What is the z-score? What's that? 150, so that's the mean. The mean's 150. What's the z-score? So it's not 150, it's not 30, it's not 60.
Or is it 15?
There's no computation involved with this one, not even a multiplication. What is the z-score? What does the z-score mean? The z-score is the number of standard deviations from the mean.
So the half?
Well, half is the closest answer I've heard so far. 1/2 below the mean. It's -1/2. That's the z-score. They give us the z-score already, because the z-score, by definition, is the number of standard deviations from the mean with a sign. So it takes that information and it compiles it into a nice compact number. Notice it took 1/2 below the mean and it combined that as -1/2. Z-score is very, very helpful. You take stats next semester, you will see the z-score come up again and again and again. It's a very important idea. So we have the z-score, which means we want to know the original data value that corresponds to that. Now the formula in general is the item minus mean over the standard deviation. So we know the z-score, we know the mean, we know the standard deviation. We need to figure out the item. So the formula I gave in class, well, there's a few iterations of it that you could use. This was one of the iterations I wrote down in class. But what this says is you take the mean of 150, and this is why it's worth knowing what the z-score is, -1/2 times the standard deviation of 30. Because it says the standard deviation tells you how many increments you go above or below the mean, and the z-score, or the number of standard deviations, tells you how large your increment will be. It may not be. So really, this is going to be 135, it looks like. Let's find out. 150 plus, really it's minus over 2 times 30, 135. So it's saying a score of 135 corresponds to 1.5 standard deviations below the mean. You really need to know what a z-score is for this test, or it's not going to look good. So you need to know what a z-score is. Does anyone have any questions before we look at the next problem? You might be waiting a while. The way to tell when a server is down, establishing secure connection at the bottom left, can't even establish that, which is one of the most fundamental communications, one of the most fundamental ways in which two things talk to each other, two computers talk to each other. They establish some sort of security. Can't even seem to do that. Means there's something wrong with my math lab. Well, what should I do? Should I keep waiting? I let out early. Doesn't seem to be very responsive. Yeah, if I knew some of the problems, see if it comes up. It's been acting up since last night, as you all know. He was working at midnight, then around sometime, 10:30, started acting up again. What a bummer. Would it just be better if I sent you all the recorded lecture for my class that I teach tomorrow? That'd be better. I mean, this is just not very practical at this point. I mean, might as well do that. It's not moving too much. I mean, I'll sit around if you want to sit around and wait. Well, that I guess that I'll send out the recorded lectures. I recorded some from last semester as well. I could send those out immediately. We actually did finish this. I guess I'll do that. If you have any questions, I'll stick around the next 20 minutes. But if not, sign the roll sheet and have a good day.